Hello and thank you for being here. Today I'm going to talk about the Alpha Energy, which is our optimal solar battery operator with the reinforcement learning approach. I'm today's presenter Jaemin and our team member is Taeyeon. These days, more and more factories and industries are using the solar panel and battery to reduce their electricity cost. But the big limitation is that the human beings cannot find the optimal operation considering the many uncertainties. Think about the solar generation. Human beings cannot accurately predict the future solar generation and also the battery degradation. When you're using the cell phone or laptop, we cannot know the exact degradation while we are using it. And the electricity demand and prices are also fluctuate at every hour. So we designed this architecture. We have a factory with the solar and battery system. And our smart AI model, Alpha Energy, will decide when to charge or discharge battery and when to buy the electricity. So our objective is to make the smart AI model to reduce the total cost of factory. And our Alpha Energy model optimizes the 24-hour operations with the uncertainties. And the Alpha Energy should be close to the ideal solution. And our model also should outperform compared to the benchmark. Next is about the implementation settings. We have 4 factors in our architecture, and I will start with the factory which requires the electricity demand. We assume that the factory needs the many electricity in the working hour. So we assign the 90 kilowatt hour in the working hour and 20 for the others. But in the reality, the demands are not strictly fixed like this. So we added the 30% of random noise to the demand for applying some realization. Next is about the electric supplier. Unlike the residential, industrial electricity price varies according to the time. And as you can see in the graph, we have the 3 levels of the electricity price. And the differences between the expensive and cheap unit price is very big, so we need a smart model to reduce the electricity cost. And next is about the solar panel. We made the prediction model for the solar generation. We used the weather observation data and the weather forecast data. With the 5 hours past observation data and the forecast data, we predict the 1 hour later solar generation. And our prediction model shows the R-squared score of the 95%. And next is about the battery degradation. As you can see the graph, the depreciation varies depending on the battery usage pattern. So the accurate degradation model is essential to calculate the degradation cost. And our Alpha Energy model can make the accurate cost with any arbitrary battery usage pattern. And next is about the results. Our smart AI model Alpha Energy is based on the reinforcement learning. And the reinforcement learning is a method that can find the optimal strategies under the uncertain information. And our Alpha Energy model trains to minimize cost with the uncertain data and solar data. And next is the ideal solution. Ideal solution uses the particle swarm optimization method. And the PSO is known as one of the optimization tools that finds the global optimal very well. And the PSO suggests an ideal solution without the uncertainties. And this is the part of the result graph, and you can see the black line is the result of the particle swarm optimization, and the yellow line is the benchmark, which is not using the solar battery system. And this is the video of the particle swarm optimization optimization process. And before we start, you can see that the particles are distributed in the space, but as the iterations goes by, these particles are converging to the one point. And this is our alpha energy model result. And you can see that our model outperforms the benchmark, which shows the 12% of the cost savings. And also our model is close to the ideal, and its differences is only the 2.2%. And this is the video that shows how alpha energy model smartly manage the electricity. And in the cheap hour, we buy the electricity to charge the battery and the factory demand. And in the mid-price, factory demand is fulfilled by both battery and the electricity supplier. And the expensive time, battery is rapidly discharged for factory demand. And same as before, the electricity price is expensive though, so the battery is discharged to fulfill the factory. So last is about our conclusion. Our alpha energy model is very economical. In our empirical result, our model can save more than 600,000 kilowatt per month than not using the solar battery system. And also our model is very fast and powerful. Our model shows the very close result compared to the ideal method, but the computation time is much faster than compared to the ideal method. And our alpha energy can be very adaptable. Our model can be applied to various environments such as the residentials or any other industry areas that needs the solar battery system. And thank you for our presentation.